So good afternoon again. Welcome to the 2013 Peton Award for Outstanding Senior Design Project and the Senior Alumni Barbecue that follows. This is, believe it or not, our fourth Peton event, and it's becoming quite a tradition here in SEAS, I'm glad to say. And it certainly is a wonderful way to showcase the talents of our students. You'll hear more a little later about the history of the Peton Award competition from Dr. Joe Peton himself, but for now, let me explain briefly how the students that you're going to hear from shortly were selected for this competition. All SEAS students must complete a senior design project to graduate. This is part of the Capstone Senior Design Project, and it's a very important part of their education because it really takes advantage of, fuses together, synthesizes all of the classes and all of the labs that they've had in the prior 3 to 4 years to take that knowledge and then put it to work to design something. Some students work in teams, some work alone, but all present their projects within their respective departments. And then from all of those presentations, our department selected the 5 teams that presented today and whom you'll hear from in just a few minutes. But before we get down to the business of the competition, I'd like to acknowledge a few guests who've joined us this evening and then introduce our judges. I'm not sure if he's here yet. He did RSVP, GW Board of Trustees member Nelson Carbonell. I don't see Nelson here, but he may stop by later. GW Board of Trustees member Scott Amy, I think may be coming later, but I don't see him here yet. Trustees are like students, aren't they? Late for everything. The chairman of the SEAS National Advisory Council, Dr. Randy Graves, is here. Randy is sitting right over there. Welcome, Randy. And advisory council members Aaron Hegarty and Will Alexander, I think, are here or maybe not here. Oh, there's Will in the front row. Just stand up and turn around and wave. Let me introduce now our panel of 11 SEAS faculty, alumni, and engineering professionals who are going to judge tonight's projects. Dr. Dennis Curtin. Maybe we can hold our applause till the end because we have 11. Miss Barbara Fleming, if you just, so you could identify yourself. Mr. Amit Kapoor. Professor Megan Lefwich. Miss Renee Lewis, Professor Romana Rafat, Professor Ergun Shimshek, Professor Zoe, and I will say it correctly, Shane Farber, Mr. Narayan Venugopal, I apologize if I did mangle that a little bit, Professor Timothy Wood, and Mr. Derya Yavala. So now let me ask Dr. Bagi Narahari, our Associate Dean for Undergraduate Affairs, to come up and explain the format of the competition and introduce the presenters. Bagi?
Thank you, Dean Darling. So as Dean Darling just mentioned, each department nominated a design project to represent them in this competition. So in this sense, before we start the competition, every one of the teams have, in a sense, already won. So congratulations to the teams. The judging criteria for the best project is it's a number of criteria. It's based on technological innovation, originality of idea, engineering design quality, feasibility of actual implementation, social and environmental impact of the project, and the oral presentation. So the judging process actually requires both a detailed poster presentation and the formal oral presentations, which is what this is, and which is about to commence. So while some of you were enjoying the sun, each team here was presenting to the judges during the past 2 hours. It probably felt like 2 years to them. And I think it's safe to say the judges, and certainly I, were impressed by the projects. So the teams are going to present a number of different ideas. They're going to present projects that will help you design an office. It'll certainly could get me emergency responders when I'm a senior citizen. It could teach us how dolphins swim, assuming you kind of know how to swim, which I don't. Design a solar-powered house and with support for medical patients. And finally, it'll teach me how to read, which I'm sure a lot of students in my class would like that, right? So during the oral presentation, each team has a maximum of 8 minutes to present, which will then be followed by 3 minutes of questions. The final awards are based on both the poster presentation and the oral presentation. So after the last presentations, the scorekeepers are going to collect the tallies from the judges, and that's going to determine the 3 winners. So the first place is going to receive a $1,000 prize in recognition at the C's graduation ceremony, and they receive an additional $200 if their project is deemed patentable or green. The second place receives $500, and the third place receives $200. In addition, each of these can get up to $100 if they're patentable or green. The order of presentations was actually determined by lots, drawn by Sandra, so I had nothing to do with it. So you can. So, teams, you ready to rumble? Yeah. All right. So, ladies and gentlemen, I'm going to start with the Department of Mechanical and Aerospace Engineering, Derek Rajdan and Alisa Tulia.
Hello, everyone. My name is Derek Najin, and this is Alisa Tullio. And we investigated the effects of adding leading and trailing edge devices on the propulsive efficiency and aerodynamic characteristics of varying camber hydrofoils. So a little bit of background first that we're going to start with. We modeled our mechanism after the swimming motion of a dolphin tail. And in nature, you can observe them and record how they swim, and you'll get an idea of how fast their tail is oscillating, and in engineering terms, this is the Struhal number. So dolphins were observed to swim in a Struhal number of about 0.3, and that's what we focused our testing on. In addition to this, we also tested the addition of leading and trailing edge devices, which have been shown to delay stall, increase the lift, decrease drag, and overall improve the performance of the hydrofoil. Some applications of our experiment are this mechanism was first designed by Matthew Baraha, and it attempts to mimic the swimming motion of a dolphin tail using a varying camber hydrofoil. Using this mechanism, we can investigate the propulsive efficiency of the motion and the flow characteristics created by the fin. There are a couple possible applications for this in like human-powered swimming devices or in an unmanned underwater vehicle. This little animation just shows how the mechanism itself works. It completes an oscillation which changes the angle of attack and the camber of the hydrofoil from about 0 to 15 degrees. And we use this to test the addition of leading and trailing edge devices.
So our objectives for this experiment were to add leading edge and trailing edge devices and test the aerodynamic effects. We also wanted to add capability to align the signals so we could run 2 runs at the same voltage and then effectively compare them. This was needed to be done because the friction exists in the mechanism, and to obtain the true forces, we needed to eliminate friction. We also wanted to improve how we measure our current so we could find the true power drawn over the motor. And in addition, we wanted to use MATLAB to look at the vortices off the trailing edge of our hydrofoil, which is another way to look at lift. So here is a picture of our leading edge and trailing edge devices. The trailing edge device was mimicked off of the edge of a dragonfly wing. As you can see from this picture, there exists some spade-like shapes on the back. This is shown to increase lift by delaying the wake and also changing the vortices behind the trailing edge. We found out the actual size of these by comparing the boundary layer on the dragonflies to our hydrofoil. The leading edge devices were designed off of a whale's tubercles, which was on the leading edge of their fin. As you can see, they're kind of these round shapes. These are also shown to increase lift. And we found the size of these off of the literature done, but every literature was done in wind tunnels, so we wanted to test this in our water flume. So the method, we were going to test a rigid hydrofoil, a varying camber hydrofoil, and 2 hydrofoils with the leading edge and trailing edge devices respectively. We did this in the water flume, which you can vary from 0 to 125 Reynolds numbers. We can also vary the Struhall number. We varied the Struhall number. We knew we wanted to test between 0 and 0.5, with which we thought our maximum would be at 0.3. To get these Struhall numbers, we calculated the frequency, which is part of the Struhall number, which gave us a period, and we could alter the voltage to find that period.
So when we're conducting the experiment, we used LabVIEW and to record the data from 8 different sources. We had 6 strain gauges, a Hall effect sensor, and the voltage across our shunt resistor, which we used to measure the power. Using MATLAB and the geometry of the force balance, which is patent pending by Matthew Baraha, we converted the 6 reaction forces into 3-direction forces, the 3-direction forces experienced by the fin. And then we converted from voltage across the resistor to current, and the output of the Hall effect sensor in location in the signal was used to align different signals. And as Elisa mentioned, there's friction in the mechanism, and we want to remove that so we can determine the true hydrodynamic force on the fin. So what we do is we run at the same voltage with the water running and then with no water running, and we align the 2 signals using the output from the Hall effect sensor and subtract the forces. This removes forces of the force of friction, the inertia of the fin, and any other things that are not force of water. This is just a quick output of the results in the raw data form. You can see there's 6 lines from each strain gauge, and the little diagram in the top right corner shows how they are aligned on the force balance. The big vertical lines are that Hall effect sensor output, which we use to align the signals. And like I mentioned earlier, we use the geometry of the force balance, which is in top view is from the triangle. First, we use the Hall effect sensor output to phase average the signals, so we get rid of everything, any possible noise or disturbances that from the flume vibrating or just someone walking by that we could measure. We phase average all the forces. The yellow line here is the computed average, and then we converted the forces into 3-direction force measurements. This graph shows 4 lines. The top line is the lift force for the varying camber hydrofoil, while the blue line near the bottom is the lift force for the rigid hydrofoil. We can see from this graph that there's a significant improvement in lift generated when you start varying the camber, and that's expected because we increase the area of the hydrofoil. The other 2 lines are the thrust force generated, which is along the flow, and there's no real statistical difference there, and we can assume that that's expected, and we have to use the power across the shunt resistor, as we mentioned earlier, to get a better idea of the propulsive efficiency. That's some future work we still have to do.
So another method of measuring lift, besides from the force measurements, were through the vortices behind the trailing edge. As you can see in the picture, that was just a picture taken with a camera of the vortice behind the trailing edge, and we implemented a ruler to measure the depth and the width. From that, you can measure circulation, which directly relates to lift. We used MATLAB to remove the background and convert to black and white, so we could do this automatically. In picture A, you can see that the depth and width are clearly shown. MATLAB can pick up those values and calculate the lift. However, that picture was taken at an arbitrary experimental values. At our experimental values, in picture B, you can clearly not see the vortex. So in conclusion, the varying camber hydrofoil produced more lift, however similar thrust. Adding the Hall effect sensor was a cheap solution that allowed us to synchronize the signals and decrease friction. In the future, we want to measure propulsive efficiency, but we need to add a filter to decrease the noise. And overall, our experiment was a success with the vortice measurement. We just need a more efficient camera to measure the small vortices. That's it. Thanks. Does anybody have any questions? Come on, someone's got to.
Could you please tell us how a Hall effect sensor works?
Sure, I can. A Hall effect sensor works when the south pole of a magnet comes in proximity to the sensor. The output voltage will go to 0, and when the other side of a magnet comes, nothing will happen. So you can just kind of put the magnet on part of it, and every time it comes near it, the voltage will drop to 0. The physics behind all that's a lot more complicated, and I don't really know, to be honest. But I know in general what they do and why it's useful here. Any other questions?
To image the small vortices, did you consider maybe using a different technique, like using a laser sheet or some way to get better contrast and get those smaller scales? Are you considering that as opposed to just using higher resolution camera?
The problem is more that the surface of the water isn't very stable. In the flume, it kind of varies. And then at the higher Reynolds numbers, and the vortices we don't actually see them at all. We know they're there, but something like that might help us see them, so it's something to look at. But with the surface level varying, it's probably not going to help too much. But again, the whole idea of that was just to kind of prove what we were doing was right, and so it's not necessary for the experiment, because we can kind of assume that the lift forces we're measuring are actually the lift forces based on simulations we did, or Matthew did. We can compare them to that.
And also, how did you use the Green's theorem to analyze the vortices?
What was that?
How did you use the Green's theorem?
Green did some research. He created vortices by applying a known circulation and kind of measured how much they deformed, or known lift, and measured how much they deformed. And he created a set of equations that, given the vortex depth, or actually given the circulation, you can predict how far down a vortex will go. So we went the other way. We knew how far down the vortex went, so we solved for the circulation. It's pretty old research, but it was a second order equation he created to fit his data.
Thank you. I think the time's up, so let's give them a hand. Thanks, Derek, Alyssa. All right. Next up is Department of Computer Science, Michelle Cano.
Hello everyone, my name is Michelle Cano. I'm from the Department of Computer Science, and my senior design project is called Text for All Ages. Currently in the United States, 32 million adults are illiterate. Their skills are at that of a 4th grade level or lower. There are traditional tools available to these adults to help them learn how to read better. These tools often involve them to sit down at a table with a heavy book for hours, or have computer access, or register for an expensive course. There has to be a better way to teach these adults how to read. Previously, you used to see this a lot on the metro, people sitting down with books. But now you're more likely to see a scene like this. Smartphones are everywhere, so why not use this as a way to get in touch with adults and help them to improve their reading skills? That's exactly what my project, Text for All Ages, does. Here's a look at one of the things Text for All Ages has. What the user is doing is they're reading current news articles on their phone. However, you can see that certain words have been left out of the text. It's the reader's job to then fill in these blanks with the correct word. They go through the entire article, filling out each blank, and at the end, they get a score, their percentage of correct answers versus all the answers they had to provide. After they've completed this article, they can view all their scores. When someone's working on a skill and trying to develop it, it's important that they know they're making progress. So this score view allows them to do just that. They can see exactly how they're doing. What you're going to see right now is the class view. One piece of Text for All Ages is the option to have classes. The idea behind this is that so many classes exist for adults in current community colleges and libraries. So this allows an instructor to be in the background. They can create a class, assign specific articles, and be the driving force behind someone's progress. The other thing that happens with Text for All Ages is the text simplification. Before the reader even sees that news article, it's simplified to meet their exact needs. News articles are normally written at an 11th to 12th grade reading level. For readers who are just looking to improve their scores, this might be a little bit too hard initially. So what the algorithm that I wrote does is it goes through and it simplifies the text automatically before they even get to look at it. Here's an example of one sentence. Icebergs are massive blocks of ice, irregular in shape. They float with only about 12% of their mass above the sea surface. This comes in at a raw score of 6.8, or a 7th to 8th grade. This score is determined using the Dale-Chow readability formula. What this formula does is it looks at the average length of sentences in terms of words, and it also looks at the number of hard words in the text. A word is determined to be hard if it doesn't appear on the Dale-Chow easy list. This is a list of 3,000 easy words that most people would understand at a 4th grade level. The first thing the algorithm does is sentence reconstruction. You can see here that the original sentence has been broken up into 2 shorter sentences. The idea behind this is that shorter sentences are going to be easier to understand than those original longer sentences. So you can see that the score has already been reduced. The next thing the algorithm will do is synonym replacement. It's taking those hard words that were originally in the text and replace them with easy words that appear on the Dale-Chow list. The new text is now, icebergs are huge blocks of ice different in shape. They float with only about 12% of their mass above the sea surface. You can see that this text has the same idea as the original text, but its score is now down to 4.9, which puts it at a 5th to 6th grade reading level. This is what the algorithm can do with just one sentence. So when it's given an entire article, it can reduce the difficulty for someone who's looking to start reading. Overall, the text simplification does 2 things. It does sentence reconstruction and synonym replacement. Synonym replacement has been one of the biggest challenges of my project. Using WordNet, I get a list of synonyms for these hard words. For example, it might give me turtle for the word capsizes. We're sitting here and we can probably guess that turtle isn't necessarily the best choice in the text for green icebergs. The correct phrase would be turn turtle, and unfortunately WordNet doesn't provide that full phrase. So here is an example of how that decision is made in terms of synonym replacement. So we'll start with the sentence, analyses of these cores and samples provide a different solution to the problem. Solution is underlined because it's a hard word. It's a word that the algorithm would look to replace as it's simplifying the text. This is the path the algorithm is going to take as it's doing that simplification. There are a lot of different steps that it goes through before it decides a good synonym to replace the word with. So first, it gets that list of synonyms from WordNet. These are the words that start out as a possibility for replacement. So for solution, from our example, you have answer, mark, root, score, term, and truth. If a word is on this list and it's easy, so it's on the Dale-Chow easy word list, it can move forward. And also, if it appears twice, it's guaranteed to be more closely related to the original hard word. So it's more likely to be an appropriate replacement. So for solution, answer and root would both be good options. Moving forward, it's important for someone to have grammatically correct sentences in front of them. As they're looking to improve their reading, they have to have grammatically correct sentences to make sure they don't develop bad habits. So the algorithm then looks at the sentence diagram. It uses a Stanford parser to get the sentence diagram, so things like a noun phrase and a verb phrase. And for our example, answer and root are both singular nouns, which matches the same as solution. So these can continue to move forward on the path. The next step is to decide which synonym makes sense in terms of the context of the article. It doesn't make sense if you have the wrong synonym in that place. The way that I've faced this challenge is with Google. I've used Google as a corpus of text to kind of get an idea of what's been said before and how it's been said. For answer, when it's done a search with the original phrase, it has 5 matches to a search that was that original sentence. Root only has 1 match. I've found that if something has at least 4 matches with the original phrase, it can move forward, and it's generally a good replacement. So in the end, solution is replaced by answer. The new sentence is now analyses of these cores and samples provide a different answer to the problem. So it's now easier to read, but it still has that same idea behind it. Now that you know the specific of text for all ages, you can look at the system as a whole. There's the instructor interface if someone chooses to have classes. There's also the database, which stores all that information needed in the tool. There's the algorithm suite, which has that text simplification algorithm. And then, of course, there's the Android devices, where people are actively making their progress. Currently, Text for All Ages has the potential to help someone here in the United States, someone who's speaking English. But it also has the potential to grow and help out 796 million people in the world who are illiterate. It can be expanded to different languages using the ideas that are already in place. If you have any questions, I'll happily answer those.
Yeah, when you go into Google, do you put the whole sentence in, or just a few words before your word and a few words after your word, or is it the whole sentence you're looking for?
What it does is it's taking just a couple of words. So it's taking a few words before and a few words after, like you said, and it uses that phrase and then also the replaced phrase, and it does comparisons with that phrase rather than the whole sentence.
You said you used a previously determined list of words that are considered easy for English language. Do you know that for expansion in the future, if there are similar lists already created for other languages, or is that something that's going to have to evolve as your program evolves?
I'm not sure if there's a specific list exactly similar to Dale Chow for different languages. In terms of expansion, it would, obviously I'm not an expert in every language, it would require moving forward and getting those experts in those languages to determine the best way. Luckily, with a lot of different aspects of the algorithm, there are already existing libraries in those languages. So there are only certain small things that would have to be changed for the different ones.
How about for the same language but different dialects? Like you've got an airporting to Australia, they've got a different vocabulary than ours. How difficult would that be to do?
Of course, so that would be a similar approach. So in terms of future growth, having those people who are familiar with those dialects and know them well, and then also looking into the different libraries that are available. There are so many different libraries available to use here for English, and that's what I've taken into account and I've used in my project. So moving forward, I think those libraries are very common and exist, and they could be depended upon.
After your final version of the algorithm, how efficient was your system in replacing it with a correct synonym?
Sure. So with the algorithm in its current state, generally it can replace the synonym at about 90% acceptance. So when it's doing that replacement, only 10% of the time is it a replacement that, to us, we wouldn't necessarily do ourselves. There have been some roadblocks in terms of developing the algorithm and allowing it to do this. So I know the one issue I ran into was how many queries I could make to Google in a specific period of time. So not having the accessibility to make all those queries has required me to kind of redesign the algorithm as time went on. But in its current state, it is fairly accurate.
You use Google to search the phrases to get the best words. Do you, after you do that search, store what you found so you don't have to do that search again? Should that same phrase come up again in another article or reading?
What the algorithm does is it takes a look, it does that Google query with that one phrase. It doesn't store it though. Once the article has been processed once, it's stored in the database after being processed. So it doesn't have to be reprocessed again. So it's fairly unlikely that the exact same phrases would come up again and again in certain articles. So the Google queries are run new each time.
Next up are Madeleine Brannan, in order, Eileen Legulu, Joshua Klein, Aliyah Dosayeva, and Philip Grater from Engineering Management and Systems Engineering.
Okay, Okay, so this is the base of our project, design of a volunteer system to assist senior citizens during a power outage. So in June 2012, a storm left parts of the United States in shambles. When a storm like this hits, the first thing that comes to your mind is whether your family is okay. You may think of your kids or maybe even your grandparents. Will they be able to get food and water and everything necessary in order for them to survive? This particular worry is a concern during the aftermath of any natural disaster. We believe that George Washington University students can help communities in the surrounding communities to help in extreme circumstances like the 2012 storm, which left 82% of Montgomery County, Maryland without power for up to 6 days.
So having this past experience of dealing with power outages where recovery assistance was somewhat spontaneous, we decided we should design a system that would organize these volunteering activities in the most efficient way. The assumption is the volunteers are drawn from the GW student population, and they are expected to undergo a training in basic disaster response skills that will be provided by an outside volunteering organization like CERT. We'll explain that later. The senior population of Montgomery County, Maryland is selected as a baseline for our model because it's one of the nearby communities that has had this previous experience of dealing with this type of emergencies. As you can see from the graph, it represents the number of households that were left without electricity after each day of an outage that took place in Montgomery County during summer 2012. We used these statistics together with other data to model our own system that would optimize the delivery of food and water to senior citizens.
So the basic structure of our design is that we wanted to have George Washington University students working with a group that's already on campus or starting their own organization, which would in turn work with an outside emergency response organization or someone who's actually certified in training people. And the actual organizations which we are suggesting is GW Responds, which currently deals with it currently works with raising awareness for crisis responses, but we want to work with them more actively and create an actual active team of students who are qualified to respond in crisis situations. And the outside organization which we are proposing that these volunteers actually work with is CERT, or Community Emergency Response Team, which is qualified to train people in different crisis emergencies, and therefore will have trained volunteers, which is really important to have trained volunteers because it's part of the assumptions that we looked at.
So one aspect of our project was designing a survey that was to gather data about GW graduate and undergraduate students, just to gather more information about their volunteer experience and their current involvement. We also asked basic yes or no questions, such as whether or not they owned a smartphone or obtained a driver's license, and this was used as inputs in our actual simulation. Finally, from this survey, we were able to gauge student interest, and from this graph, we can see that 70% of students would actually be willing to volunteer at least one shift in the aftermath following a power outage.
So one of the tools that we created was a web application. This is obviously just an HTML website, and part of this is so that when people are going door to door to find out what senior citizens actually need help, since a large part, well, almost all of our volunteers have a mobile device, a smartphone, they can access this website and fill out the form. So this is one tool to recording, which would then be put in the system for requests.
So this diagram shows us a pretty basic outline of our design system, and it also summarizes our simulation model. So the overall sequence is that a request is received via the web application, the volunteer distributes the food and water, and finally the senior citizen needs are met. Within distributing food and water, there are basically three main events that occur. The volunteers are transported to a base site, they participate in a brief training session, and finally they are assigned to a senior citizen household.
Okay, so, and to effectively design a volunteer system that we can put into place, we looked at what variables we should focus on when we implement the system. So we looked at the number of volunteers, how many volunteers are going to show up that can help us out. Then the number of hours we would work per day. Then the number of vans we would be using to drive the volunteers out to the districts of Montgomery County, for example. Then the average distance or time it takes from the base station to get to the individual districts. then how many food and water requests we could fulfill per van, and the number of volunteers we would have in each van. So I stay with the colors Eileen just presented to walk you through our model. This is a discrete event simulation model that we use to measure the influence of those variables. So the first part, as you can see, is the volunteer arrival, the training, and the shift assignment of those volunteers. The second part would be the grouping of those volunteers, assign them a van, assign them a group, and then assign them a district and a number of requests they would have to fulfill, and then they will drive out to the districts. Then we go to the submodel. This is the same for each of the districts. And so here we are recording, or the food and water requests come in, and we group them in as many requests we can fulfill. The volunteers come in, they distribute the food and water, and then we record the requests we can fulfill. And in the end, the volunteers return to the base. If they have shifts left working for that day, they go back into the system, or they leave and just go home. So running this model, or running this discrete event simulation model, we had an average of 55% requests that we could fulfill. And then we used one-way sensitivity analysis on each of the variables to see which one is most influential and we should focus mostly on. So we come up with the number of volunteers is the most influential variable, because increasing the number of volunteers by 20% would help us to fulfill more than 25% more requests per day. And the number of vans is the least influential variable, because how we ran our model, they were not completely utilized. So increasing and decreasing the number of variables had no influence on the number of requests we could fulfill.
From our survey, we have found that students are interested in helping senior citizens in nearby communities, but willing volunteers need to be trained and organized, and therefore a management hierarchy system must be put into place in order to accomplish this. The findings from our design of our system that include the general structure as well as parameters that influence the system can be used to develop an efficient crisis response team here at GW, and we hope that in the future other universities can use our system to model similar programs at their schools. Thank you. And we're opening the floor to questions.
I was just wondering how someone would go about using the system if they didn't have power. Would they sign up for this beforehand, or?
So the idea is that we have a day where the volunteers are assigned to going door to door, and so if they didn't have access to the web application, then it'd obviously be done manually, but we account for the actual recording of the names at each household.
So with your web application, if the cell service goes down in an area, what's your solution for that?
So if the cell service is down and they don't use the web application, it's just a way to electronically do it if the cell service was up in parts of the district. Just so that you don't waste paper, you can use a quick formatting tool. But we have a day where they go and record it. Any other questions?
Why are you not on the stage? Please.
5 people, 7 minutes.
I was just wondering what percentage of the population responded to your survey?
Percentage of GW students?
Yeah.
We had 102 respondents combining graduate and undergraduate students.
Which is for an online survey. Nowadays, a relatively large amount of people who actually do it without getting paid or without getting a food voucher. So we're happy with that.
I have a question. I don't know if this is kosher, but Have you guys tried integrating your web application with, like, I noticed that you guys had a place to put the address, maybe integrating that with Google Map or some other application where the volunteers can see where the help is needed, or did you guys attempt that?
So we actually demoed a more comprehensive application, but we kind of decided that part of the issue is a security risk, so you don't want a bunch of people knowing where everybody, who's a senior citizen lives. So we wanted to keep it more contained where only certain coordinators see the addresses of people and then they distribute those individually. But yes, we have a demo that does Google Maps.
Okay.
You don't talk.
Guys ready? Okay. So next, from the Department of Civil and Environmental Engineering, we have Claire Silverstein, Jason Robertson, and Tara Fogarty.
Hi, we'd like to start today by thanking everyone for coming and coming out and supporting all the projects here today. Our project was the Bellcrest Center office building. This building is located in Hyattsville, Maryland, adjacent to a metro. It's a 15-story building. It has retail located on the first floor and a mechanical penthouse located on the roof. The estimated cost of this building for the steel and concrete is $9.3 million. Our building will function as offices for a medical insurance provider, and in the event of a natural disaster, this building will serve as an emergency communication center. The design components of our building include determining full gravity and lateral loads. These loads include the snow loads, rain, wind, in the event of seismic, being an earthquake. We had to develop from these loads a framing plan including all the beams and girders, lateral frame design, column design, foundation design, and connections.
So in order to begin our design, we needed to look into two different codes. The first code was the International Building Code, which was stipulated by Prince George's County, where our building is located. Furthermore, we had to look into the minimum design loads for buildings and other structures, or ASC 7 and the 10th edition is what we used. By using these two codes, we kind of got more of a sense of what it will be like when we actually do work for a design firm in the future. So going more into one of the types of loading, seismic loading, which, as Tara said before, comes from earthquakes. We were able to use ASC 7-10 to look into two different methods. The first method is the equivalent lateral force analysis method, and this is a method that is the most simplified form, and it is the most conservative in the forces that it produces. This, as you can see in the picture on the right, it has very linear loading. So it takes the effective seismic weight from each level and has a distribution factor that it accounts for, and has the highest loading on the top and the smallest loading on the bottom. By using the second method, which is modal spectral analysis, we were able to actually look at how the structure behaved using MATLAB code. And when an earthquake happens, it doesn't just move one direction. It vibrates back and forth in a sinusoidal motion. And so as you can see from the loading on the left, that's how our structure is moving, and the loadings are corresponding to that. By doing this analysis form and comparing the two and then using the smaller loads, we still had enough factors of safety to create a safe design, but it was more effective and efficient because we were able to reduce this load by a significant amount, with the highest value being reduced by almost 50,000 pounds. By reducing this load by that much, we were able to cut down costs by reducing the amount of steel, which in the end I think gives us a great idea of what working in the future will be like, and being able to market our skills and create buildings like this for a firm.
The major portion of our project included the design of a lateral framing system. As the primary element of resisting lateral loads from earthquakes and wind, this kind of ties the whole building together. So our finite element model had to include several elements of our framing plan, including building and roof and floor girders, columns, and then the lateral brace. Floor girders were also modeled using composite sections based on the flooring, based on the floor deck that we chose for the building. We utilized Stab Pro to create our finite element model, and then we had to test 4 different load cases over 8 separate load envelopes. Finite element modeling is a very beneficial tool to civil engineers. So using finite element modeling, in particular Stab Pro, was a very educational experience and is very good preparation for work out in the field. We would like to conclude by kind of talking more about what we learned from this experience. We certainly didn't develop a new product for you, but what we've done is we've really integrated all of the 4 years of civil engineering education that we've received here at GW. We've learned how to process and deliver a major civil engineering structure in terms of scheduling and milestones. Additionally, we've also developed our engineering sense. This is the professional engineer's greatest tool. It's going to help us design things in the future that will be safe for people to occupy, which is our primary goal. We would like to acknowledge our department, and particularly Dr. Silva, who is our professor, Dr. Mazzari, Dr. Badwan, and Professor Tin, as well as Matthew Haringa from SKNA Engineers. And we'd like to thank the school and everyone for coming out today.
As always, we'll take questions.
Yeah, the seismic load that you showed, what was the size of the earthquake? And you said there was some sinusoidal motion. Did your model show the actual motion of the structure?
It did. The size of the earthquake wasn't necessarily taken into account. We did use USGS resources in order to install their path, I think, which is based off of about 20 plus years of data for the location in Maryland. So we were able to take ground, so spectral acceleration factors, which is how the ground will move in that particular location in case of, what they would expect is, the, I guess, biggest possible type of earthquake. And then we didn't have it on the slides, but on our poster, we showed the 2 governing modes for 90% of the modal participation. So it does show that, the first one is very linear and the other one has that curve. And so we were able to kind of work with that and get the forces accordingly.
Okay, the next one is from the Department of Electrical and Computer Engineering. And the presenters are going to be Caroline Litchfield and Damon McCullough. And for the judges, there's 10 people on the team. They're going to stand by the side because there's not space. So don't worry, they can answer your questions.
Okay, we're last, so you're almost done. All right, hi everyone. My name is Caroline Litchfield, and I am part of the Solar Decathlon team representing the Department of Computer and Electrical and Computer Engineering. I've worked on this project with Scott Baker, John Gearhart, Damon McCullough, Ben Miller, Asma Mnebi, Chris O'Brien, Loreto Pintano, Josh Rooks, and Joshwan Sheng. Professor Tom Minucha has been our mentor, and Professor Kim Rodis of the Department of Civil and Environmental Engineering is the faculty coordinator for all of GW for the Solar Decathlon team.
All right, I'm Damon McCullough, one of the biomedical engineering students working on the Solar Decathlon. And the Solar Decathlon, run by the U.S. Department of Energy, is an international competition that challenges 20 collegiate teams to design, build, and operate a solar-powered home that is cost-effective, energy-efficient, and attractive. The Solar Decathlon is held biannually, and Team Capital DC is participating in the 2013 competition. Each house is designed and built by students.
The goal of the Solar Decathlon competition is to create a net zero energy home to be used in Irvine, California that is between 600 and 1,000 square feet. Team Capital DC has decided to make a house that will be dedicated to a recuperating veteran and increase the quality of his or her life at home. Team Capital DC draws talent from 3 universities. From Catholic University, architecture, from George Washington, engineering, landscape design, and interior design, and from American University, marketing and communications.
And this is what the Harvest Home will look like from the outside.
The house will collect energy from the sun through solar panels on the roof and turn it into electricity to power the house. The photovoltaic system outlined in this presentation cannot be used in the actual competition due to the Department of Energy safety regulations. It mandates that any commercially available product must be bought commercially. Our project here mimics the technology that will be used in the house and adds unique features such as the solar concentrator with thermal cogeneration, which is new on home-sized units.
And the Harvest Home will also have 3 innovative biomedical monitoring systems, sleep, gait, and activity monitoring. The biomedical systems make summary data available remotely to authorized medical professionals as well. This feature is pioneering innovation in combining biomedical monitoring systems, new algorithms, custom analysis and display software, as well as smart homes. Now, to have a social impact on returning veterans, homes can assist with rehabilitation and healthy habits. With a floor system that monitors gait, the home can help them follow their own improvement and identify decline. With a computer vision-based monitoring system, homeowners can discover disturbances in their sleep, and with sensors to detect activity, personal rhythms are reported to encourage a stable lifestyle, resulting in improved mental health. Now, the leftmost image depicts the force plate module of a new, inexpensive gait monitoring system. It collects data on the balance and gait of the subject by determining and tracking footfalls and his center of mass as he walks across the plate. This is done without using the large conventional monitoring equipment found in rehab labs or any kind of obtrusive, in-shoe, or otherwise wearable electronics. The raw data from the load cells is processed in real time by tiny microcontroller chips, unique algorithms, and custom display software. On the right, you see one type of output, in this case, a white dot, which is the center of force, moving on the computer display as he walks across the plate. This system is unique because it is inexpensive, small enough to be installed in a home, and will allow the user and his rehabilitation team to monitor his recovery from a gait-affecting injury. Small, custom-designed wireless, battery-powered sensors and microcontrollers monitor the occupant's activity throughout the home. Events are recorded and displayed by the home's computer for the homeowner and his medical team to see, share, and use. This system is very flexible and can reveal healthy, consistent habits versus lethargic or erratic patterns. Such patterns supplement unreliable self-reported data and provide valid input in behavior analysis by counselors or medical professionals. And this data also aids in energy efficiency by providing input to the home's utility control systems and issues ranging from how to analyze point process data, like certain events, to privacy concerns had to be addressed in the development of this system. With sleep monitoring systems, it's actually an app for the Xbox Kinect, which intends to diagnose periodic limb movement disorder, or PLMD, and also restless leg syndrome by analyzing sleep motion for localized periodic movements of joints and then uploading the process data to a FTP site or website. Now the figure on the left shows the Connect program tracking the joints of a sleeping person, and the figure on the right shows the frequencies of those movements over time. Extracting this information has required development of highly algorithmically complex software which delivers concise information that has never been readily available to medical professionals.
The photovoltaic team designed and built our system from the level of individual modules and took it through integration of all modules. Here, the orange dot will guide us through the power flow of our system. First, the source of power is the sun, which is then concentrated by the solar collector, maximized by the maximum power point tracker, changed from a DC signal to an AC signal with standard parameters by the inverter, and the SSR for the inverter and the grid act as safety systems, which then transfer power to the load or back to the grid for credit. This diagram shows the flow of information through our system. The blue lines show monitoring information like voltage and current on the lines, and the red lines show emergency shutoff signals from the safety system in case something goes wrong. The solar collector focuses the rays of the sun onto the point of the solar panel from a wide area, enabling more energy to be produced from a smaller amount of solar panels and at a lower cost. It's innovative because of the fact that it is used widely on an industrial scale, and this is one of the first times it's being used on a household level. Here's what the solar collector looks like. We need to verify that the solar panel works as dictated by the manufacturer's specification sheet. This graph represents current versus voltage output, and you can see that we get maximum current and maximum voltage when you have the greatest irradiance by the blue trace here with 1,000 watts per meter squared. A solar panel might not work to the best of its ability due to changing factors in the environment, partial shading, temperature, so we use the maximum power point tracker to adjust the output voltage and deliver the maximum power to the load. The inverter allows solar panels to power a house by taking in a DC signal from the maximum power point tracker and turning it into an AC signal at 120 volts and 60 hertz, which is the standard outlets. The sine wave is created using pulse width modulation. Here's a view of the inside of the inverter. And the monitoring and safety system work together to respond to unsafe conditions and report power consumption data. Thank you.
Thank you. Yeah, so any questions about our systems?
What are the top design features that's going to allow you to win the competition? Would you say the top 2 or 3?
Well, first, the whole competition has always been about solar efficiency. So first off that, they compare the amount of energy drawn from the home to the amount of energy created by the home. And with that created energy, you can actually end up contributing energy to the grid at certain times of the day. So that's been the priority with construction of the home. And we're actually at the point where the home can generate more energy than it requires at most times. So I'd say that's the top priority. Second.
That would be the top priority, but also the biomedical aspects are not frequently used in other homes. This is a totally new sort of spin we're putting on the house. So that will be very innovative and exciting to see, and I think that will make the judges very interested.
Could I ask you whether or not you looked at the cost factors? I mean, one of the problems with solar has always been it costs so much, and you mentioned a little bit at one point where your reflector was able to use a more commercial and smaller solar panel that was available, I assume at less cost. Yeah. Were there any other cost issues that you looked at as part of your project?
Affordability is a really important part of the decathlon, and so that's always taken into consideration. So the collector actually reduces solar panel costs per area by like 30%, so it's fairly significant. So using that reduces our cost a lot. I don't know about the biomedical.
Oh yeah, with the biomedical costs, overall, the whole drive of it is to reduce the amount of visits to the hospital and the amount of time that you'll spend in rehab. So the costs of this are pretty hard to measure if you're gonna put it in those units. But
well, this application was for a handicapped person only. I mean, that was the
For certain parts of it, yes. For the gait analysis, it's potentially for veterans returning with leg injuries, but the rest are for anyone that's using the home in general. Yeah.
Were you able to measure the efficiency of your inverter system?
We were.
Yeah.
I'll let Josh talk to you about that.
Yeah, please.
Yes, we were. We were able to test the overall efficiency of our inverter system by comparing the amount of power that we were taking in versus the amount of power that we were producing to the light bulbs as measured by Carly's power monitoring system. And we found, for the most part, our inverter system to be from between 55 to 67% efficient, generally above 60%.
All right, here's the last question. Thank you.
I did have a question actually for the last presenters, was if the computer does detect lethargic behavior, does it offer any advice on what to, what to do? Well, thank you, students. That was, we've covered a lot of ground there in those 5 different presentations, so I think the judges are faced with quite a difficult challenge. The event staff now are going to have to collect the judges' results and tally them up, and we'll give you the results a little bit later. But while they're doing that, we have a few short presentations to share, including a brief presentation by Dr. Joe Peton. This competition is named after Joe Peton for 2 reasons. About 4 or 5 years ago, he dreamed up the idea, and not only that, he provided some funds for us to execute the idea, so we're very grateful to him. Joe Peton is a former faculty member of our ECE department. And this award, as I just mentioned, was established 4 years ago in 2009. I'm going to invite him up to say a few words about the history of the award, but before that, let me say a few words about him. It's actually hard to say a few words about Joe, because if you look at his resume, it's pages and pages and pages long of accomplishments. So I really have to summarize. Over the course of his career, he taught not only here at GW in SEAS, but also at American University, at Georgetown, University of Colorado at Boulder, and the International Space University. And he has won several awards for teaching excellence during his career, and he's held several leadership positions in those institutions. These include serving as director of the Interdisciplinary Telecommunications Program at University of Colorado at Boulder. He was director of GW's Space and Advanced Communications Research Institute, and he was director of the Accelerated MS program in Telecommunications and Computers at our own Virginia Science and Technology campus. He founded the Arthur C. Clarke Foundation in 1983. He became the founding president of the Society of Satellite Professionals International in 1984. He served as the chairman of the board and dean of the International Space University in the 1980s and 1990s. He's the past president of both the Global Legal Information Network and the International Space Safety Foundation, and was the director of strategic planning and project share at Intelsat. Should I tell you more? He's been an incredibly busy guy. Joe is carrying a book, you'll notice, when he comes up. He carried it when he came in. And in my notes, I had said, well, I'm going to tell the crowd, Joe, that you're the author of more than 30 books. And he said, well, this is actually number 40. So this is quite, he's really, truly prolific. He's a member of the International Academy of Astronautics. He's a fellow of the International Association for the Advancement of Space Safety. And he is the winner of the Arthur C. Clarke Award. So Joe, I've delivered 2% of your resume. Please come up and say a few words.
Well, here's a copy of the book.
Great. Are you perfect? Thank you.
So, it's a bad form to correct the dean, but actually this award is not about me. It's actually about my forefathers who actually are inventors. The real purpose of this event, of course, is to spur innovation. About 3,500 years ago, Socrates said there's only one evil, ignorance, and there's only one good, knowledge. And that's what this is all about. But there is more than one good of knowledge. I say tonight we are looking at the 3 I's, and those are innovation, inquiring minds, and initiative. And you young people have done all of those things and shown that very well tonight. But first, a news flash. May 2013, planet Earth reached a new milestone. We today went over, not today, but this month, we went over 400 parts per million of carbon dioxide buildup in our atmosphere. That serves to heat things up and to fuel climate change. Of the 5 mass extinctions that come about every 300 million years, 4 of those have been due to climate change and heating up of the environment. So, green engineering, which is part of this competition, is important to life on our planet. Now, a few words about the Peton family and green engineering. There was a man named Lester Allen Peton who moved to California during the gold rush. And in the 1970s, he invented the Peton water wheel, which is 5 times more efficient than a conventional water wheel. He then next went on to invent the high compression hydroelectric generator, which is used today in our dams around the world and is indeed an important green power for planet Earth. He is today in the Inventors Hall of Fame. In 1903, Edward Peton, my grandfather, invented the corn picking machine, later manufactured by the McCormick Company. And my father, I.W. Peton, invented at Badger Meter what was at the time the world's most efficient device of its kind in the world. Unfortunately, that was a parking meter. We don't brag about that quite so much. So far, I actually have managed to write some 40 books, but there's a problem with that. I have managed to publish all of my good ideas, and therefore they were not patentable. I am hoping that you will be smarter about that and maybe go on to patent some of the good ideas we've heard here tonight. So I did want to say a few words because I think they're relevant to The Safe City, which is my new book. It is about megacities and the fact that we are seeing today a lot of cities more than 10 million in size. And in fact, what we're seeing is that many of these cities, like Dhaka, Mumbai, Sao Paulo, Delhi, Lagos, are doubling as much as every 8 years. Lagos, which was a short time ago only 3 million, is projected to be 40 million people by 2040. And at that time, Nigeria will overtake the United States as the world's 3rd largest country. Unfortunately, as documented by the World Bank, 80% of this new development in most of these megacities are slums without adequate water, sewerage, energy, transportation system, and certainly education and healthcare services. So my new book, The Safe City, is about creating what I call meta-cities, new cities using new architecture, new technology, new systems to hopefully overcome some of these problems. If I were to try to summarize what is the thesis of The Safe City, is that urban sprawl is bad, urban density is good, but super urban density, where you have more than 10 million people living together in very crowded conditions, this can be bad again. So the idea is to create new models for our development. So what we need is to find new solutions, and that's what this competition is all about, and this is why I commend to you to continue what you have started here. A lot of the Peton family have tried over the years to invent new and better things, but now it's up to you. And so I would like to thank you all for your efforts and to call Will Alexander, the head of the Engineering Alumni Association, up here to continue our discussion. So thank you very much.
Good evening. How's everyone doing? All right. I've been invited up just to make a few quick remarks. One of the first things I'd want to do, if no one has preceded me in doing so, is officially welcome you and congratulate you as the class of 2013. You made it at this point. I don't think anyone can hold you back. Commencement, aside from the dean. So check with him before you go out to the barbecue. One of the reasons I was asked to speak, since you guys are being ushered into alumnihood, if I can make up that word this evening, is that I am now the outgoing chair of the Engineering Alumni Association, which you all are now de facto members of. So welcome. One of the things that the EAA exists to do is to essentially be a body, a resource, an opportunity for what really amounts to be a very powerful group of engaged alumni to come together, share ideas and fellowship and resources, and to kind of steer you new recent alums into the progression of who you are going to be in the future, and then to connect us with the current students so that we can be of benefit and in a way pay it forward for all of the support and guidance that we were so fortunate to get during our tenure as students. I want to drop just a couple of names since I'm going to be fading into the background a little bit. Pascal Dumy will be succeeding me as the chair, so you can look forward to receiving correspondence from her. Bethana Shukri is our most valuable resource. She's in the back corner in a lovely outfit, might I add. And she is invaluable to Pascal and I in the execution of our duties. She's our on-the-ground point person. She also steers us and herds us into the right direction to make sure that we're on top of the things that are going to be of benefit to the students and to you guys as alums. One of the, I guess, parting things I'll say, because I've always learned you never want to be the guy that stands between anyone on their way to food or beverage, and right now I'm in the way of both. But what I'd want to part with you in my remaining minute or so of time is that there is a tremendous amount of advice and goodwill that folks will want to offer to you at this turning point in your lives, and at the risk of not trying to repeat something you might already know or belabor the issue anymore, I want you to try to synthesize all of it and figure out what benefit it has to you guys in your lives. One of the things I noticed while sitting here and listening to the presentations was that there's an overarching theme of the 5 teams that presented in wanting to really make an impact in the world and helping others, whether it's the text messaging program, helping people learn to read, some of the interesting facts that I didn't realize were in the solar decathlon, the biomedical aspects, even the buildings that we construct, which is near and dear to me because I'm a general contractor, all enable people to live and carry on and gain the most out of their lives. And I didn't know that going into engineering, that we have the potential to impact the well-being of our fellow men and women on this planet. And so that is a tremendous charge for you. It's not just equations and formulas and books. You really have a heavy burden in terms of being able to direct the course of the world, essentially. And so I guess my one bit of advice for you guys as you're preparing to shoulder that load is to take the time to look out for your wellness. Do the things that you need to do to re-energize yourselves, maintain your health, maintain your connections with family, because these are the things that will sustain you and will allow you to give more of yourself in whatever it is that are your pursuits. There's a lot of times it's, I guess, admirable to be selfless, but if you continue to give more and more of yourself in a selfless way, there's less and less of yourself to go around. So don't forget to take care of yourselves as you go about taking this world by storm. With that, I would like to now introduce Caroline Litchfield, whom you heard from earlier, to speak about the specific benefits that that being an alum and what your responsibilities are to your alma mater. Caroline?
Okay, hi again, everyone. So I'm your senior class representative to the Engineers Council, in case you didn't know that, but I won't be for much longer. But yeah, okay. So first, I want to say congratulations to everyone here. You've made it through 4 years of all-nighters, long lectures, and much-needed happy hours. Shout out to Lindy's. You have survived over 100 academic credit hours and earned yourself a valuable degree in engineering or computer science. Despite the importance of academics, this education has been about much more than credit hours and classes and grades. It's been about traveling to El Salvador to build latrines with Engineers Without Borders, or teaching new students the ropes, literally, with C-SPAN. Or it's been about busting a move at the Engineers Ball, or designing the mini Baja, or even starting the journey towards becoming a real person through an internship your professor helped you find. All of these things make GWCs the great school that it is. And they are all able to happen because of the investments others have made in the school and in each of you. Professors have believed in you, parents and siblings have guided you, alumni have invested in you, and friends have given you everything else. When you leave C's, don't really leave. Stay connected, host dinners, plan events, do whatever the notion of giving back means to you, so that future students can have the great experiences that you did. In my opinion, one of our favorite childhood poets, Shel Silverstein, says it pretty well. So here is a poem called How Many, How Much. How many slams in an old screen door? Depends how loud you shut it. How many slices in a bread? Depends how thin you cut it. How much good inside a day? Depends how good you live 'em. How much love inside a friend? Depends how much you give 'em. So remember to give back and that your relationship with GWCs is far from over. Thanks, everybody. And yes, now back to Dean Dolan.
Well, thank you, Joe and Will and Carly. Correcting the dean is perfectly fine. It's actually a sport in C's. And it should be. We're engineers. We work in teams, and nobody's ever right all of the time, except me. So corrections are just perfect. And I'm going to correct Will and say that I'm the person between you and the food. You were one of the people. The judges' results are actually ready, and so we didn't know when they would be ready, so I had prepared with the help of Joanne some points I wanted to make, and they would take about 30 minutes, 45 minutes. If the judges were having a hard time, I'm going to really condense this down very quickly because, but there is something I would like you to see, and there are one or two remarks I would like to make. Don't run that yet. Before I do that, though, I do want to say a special thanks to you, Will. You've taken on a big task in the last few years. You've done a terrific job, and thank you very much for everything you've done. I wish you great success in your new post, too. The gist of what I was going to say, if I had my 30 minutes, which I don't have now, is going to be really just a few words about the transformation that's going on in this school and has been going on for some time. And one of the biggest symbols of that transformation, as we all know, because most of us, at least students and faculty and staff and many of the guests here today, judges, walk past the site every day, is the SEH. This is a short video. It is quite short. I think it's about 30 seconds. It's about of the last 18 to 20 months. It's condensed into 30 seconds. I think it's worth taking a look at and enjoying. So will you run it? Wow. If you have watched this day by day by day and seen that 1,100 car park, multi-story 1,100 car park come down, the 72-foot deep city block size hole dug, and then the concrete starting to come out of that, you would be, I think you have renewed respect for civil engineers, renewed respect for construction management, at least I have. I'm really impressed with this. If you've looked down the hole today, you'll see that the first four floors at the bottom, 6, 5, 4, and 3 are in. That's the car park. The next two floors, lower level 1 and 2, where there'll be labs and space for us. Those are just coming up now, and it won't be long before we're at grade level. And a few months after that, the whole 8 stories will be up. And believe it or not, does everybody know when we move in there? It's December 2014, January 2015. It's really not far away now. It's about 18 months away. I had a few sad things to say. I wanted to say, I imagine our graduating seniors who've just watched this video, they've watched it with some mixed emotions because you're thrilled that SEAS is getting a new world-class engineering building, but you'd probably be a little more thrilled if it had been completed 3 or 4 years ago, right? And you had spent 4 years in it. I wish it had been finished in time for you, but it hasn't. But it will help increase admissions applications in the next few years. It will certainly strengthen everything we do from instruction to research. And as SEAS grows in strength and reputation and selectivity, the value of your diploma will appreciate. So this is an investment for you also. One other thing that I wanted to mention, another sign of our progress, I think, which graduating seniors have had a real opportunity to benefit from, is in the last 3-4 years, we've hired 37 new faculty. We have about 95 tenure track faculty total, so that's about 1/3 of the faculty we have now have been hired in the last few years. This year, we were recruiting for about 6 or 7 more. We'll fill some of those positions. Competition is heating up out there. There's been a little bit of a recession, a little bit of hiatus in faculty recruitment across the country. It's really now picking up, and it's becoming increasingly competitive to attract people, but we will be attracting people, trust me, because of the quality of what we have to offer, the building, and so on. Most of these new faculty, in fact, all of them are coming from a wide array of engineering programs from not just across the United States and highly ranked programs across the United States, but across the globe. And that's part of the trend here at GWs. You know, we're going to become, if we're not already, a truly global institution. I think SEAS has, in fact, been leading the charge for the rest of the university on that, because we have a very, very diverse undergraduate body and a very, very diverse graduate body. One thing I always say about the undergraduate body, a fact I'm very proud of, and many of you have heard me say this many, many, many times, but I'm going to repeat it anyway. I don't care if you've heard it many times. We are now 39% women students at the undergraduate level. That's twice the national average. Our graduating class will be about 32% women on Friday. That's really quite something. If we could nudge that up, as we will do, I think, over the next 2 or 3 years, 2 or 3 percentage points will certainly be in the top 10 in the country for graduating women engineers. So that's really, really positive. I have a lot more things to say. I had an array of dean jokes to tell, if anybody would like that, but maybe we should move on to the results of the competition, because I know that's really what you're waiting for. So Sandra, the envelopes. Third place award, Derek, I'm afraid I'm going to mangle your name, Derek. Derek Najzin, and yeah, I got Derek right. I know that. I apologize. And whoa, hold on. And Elisa Tullio, Department of Mechanical and Aerospace Engineering, for their project entitled Investigating the Effects of Leading and Trailing Edge Devices on the Propulsive Efficiency and Aerodynamic Characteristics of Varying Camber Hydrofoils. They'll receive a $200 check. Second place award to Asmay Nebi, Christopher O'Brien, Damon McCullough, Scott Baker, Carolyn Litchfield, Xishuan Shang, Benjamin Miller, Joshua Rooks, John Gerhardt, and Loretta Pantano of Department of Electrical and Computer Engineering for the Solar Decathlon House. This team will receive $500 plus an additional $200 because their project has been deemed both green and patentable. So congratulations, guys. Come on up. And first place award goes to Michelle Cano. Where is she? Just 1 second, I have to read a little bit more. Come around the side, that's fine. Don't be shy. Department of Computer Science, as we all know, and her project was entitled Text for All Ages, Mobile Adult Literacy. And she is going to receive $1,000 plus an additional $400 because her project has been deemed green and patentable. So congratulations.
We had no idea that the ECE team would be quite so large. So I'm going to try to add to the award so at least each member gets $100. So.
Excellent. So I would like to, I'm going to wrap this up quite quickly. I want to thank all of our judges. They did a lot of work. They're all volunteers, and your contributions are greatly appreciated by us and everybody else here. So thank you. I want to thank the students and, of course, the faculty mentors. I think tonight's event, I think back 4 years to the first one of these. I think this event is just another symbol, too, of the school's progress. The quality of the projects, I think, reflects the increasingly strong quality of the work the students are doing. And if you want to see more of the graduating students' work, I recommend that you visit the Senior Design Showcase tomorrow, when a larger number of students will be displaying their work in Tompkins. That starts at 11 a.m. if anybody's wanting to attend that. We are going to now have a barbecue and some real drinks for those who are old enough to participate. Each of the years that we've had this, the barbecue has been sponsored by 3 of our alumni, 3 members of the National Advisory Council, Scott Amy, Ashok Jha, and Howard Tischler. I'm not sure if any of them are here yet. 1 or 2 of them were supposed to be coming, but I'm not sure if they're here. But I'm very grateful to them for sponsoring that event. And I'll wind up by thanking the staff for all the work they've done. This is a fabulous event, and next year we'll have a 5th one, and it will be even more fabulous. So thanks, everybody. Let's and the final thing, which I always forget, and Sandra only reminded me 30 seconds ago, we want all the winners back on stage because we want more photographs. So please come up. There will be barbecue left for you. Don't worry.